we are talking about similar polygons, similar figures. We are going to be able to understand what they mean and how we can use them. And we'll be using similar figures for a long time here, so it's going to come up over and over. So, similar polygons. What is a polygon?
4 sides.
It's a shape, yeah. It can have 4 sides, but it's also a 5-sided shape, a 6-sided shape, any size, yeah, 3, 4, 5, 6 number sides. It's a flat, two-dimensional shape. So a triangle, a square, a rectangle, a pentagon, hexagon. These are all polygons, okay? Excuse me. Polygons with the same shape, same exact shape, but a different size, are called similar polygons. They have the same shape, but maybe one is small and one is big. It's an enlargement or a shrink, okay? It just gets scaled up or scaled down, all right? Polygons are similar if corresponding angles are congruent. Corresponding angles are congruent. So we've got pairs of congruent angles. So all the angles are going to be exactly the same, but it turns out that the corresponding sides are proportional, which is the word of the day. We're going to be writing lots of proportions. So proportional, they're not exactly the same, but instead they are scaled up, meaning if I know that my little rectangle has a side length of 2, and I have a bigger figure that is scaled up, maybe it's 4 times as big. So that side of 2 just gets multiplied by 4 and turns into an 8, okay? But all the sides would do that as well. So the long side on my rectangle maybe is 10. It gets multiplied by 4 and becomes 40, all right? So that's what it is. We're taking a figure and we're maybe scaling it bigger, or taking a figure and shrinking it down, okay? And so that's what it means to be proportional. We can multiply it by something to make it bigger, or we can multiply it by something to make it smaller, okay? The ratio of corresponding sides is called the scale factor. All right, that is the ratio of corresponding sides. The ratio is a fraction, so we get to compare corresponding sides. And if polygons are similar, then their perimeters are also proportional. All right, so we want to look at scale factor a little bit here. What is the scale factor of triangle ABC to triangle DEF? You can see here we have triangle ABC, and the bigger triangle is DEF. And you'll also notice that we have 3 pair of corresponding angles that are congruent. So angle A is congruent to angle D. It's really important that we recognize that. Angle B is congruent to angle E, and angle C is congruent to angle F with those triple marks, okay? Because those angles all match, these figures are the exact same shape, but we can see clearly that one is smaller and one is larger. Now, what I want to do is I want to compare the corresponding sides. So I'm going to look here, and I want to write the scale factor from ABC to DEF. So I'm going to start here with triangle ABC, and I'm going to say, hey, I have this side that's length 8. What's the length of its corresponding side? Which side does 8 correspond with down here? 12, yes. Yeah, so we have this side that has a single arc mark and the double, and that compares with this side that also has the single arc mark and the double. So what we have is the ratio of 8 over 12. Let's look at side 10 here. What side does that compare to? 15. So 10 over 15. Let's see what that is. 10 over 15. And then the last one here, we have 14 compares with 21. And I'm just marking them with markings that are similar. So we have 14 over 21. Now, what do you notice about all of these little ratios here? Let me
you can reduce.
You can reduce all of them, yeah. 8 over 12 is 0.66667. No. Hey, 10 over 15 is also, and 14 over, whoops-a-daisy, 21 is also? Yeah, 6, 7, okay. We can math fraction. All right. So, I'm illustrating to you that when we have similar figures, the corresponding sides are proportional. All of these, for instance, 14 over 21, we can divide top and bottom by 7. It reduces to 2/3. All of these reduce to 2/3. They are all the same ratio. So this is the scale factor. What is the scale factor of DEF to ABC? Well, if I want to figure out the scale factor of DEF to ABC, I'm going to start with my DEF. I'm going to say, hey, I'm going to look at this side that's got a length of 12.
So 12 over 8.
And that corresponds to the 8, yeah. And then, of course, I can reduce that. Both of these divide by 4, and if I divide top and bottom by 4, I get 3 over 2.
And it'd be 15 over 10, and then 21
and
over
they'd
14.
and they'd all be 3 over 2. So this is the scale factor from the bigger triangle to the smaller triangle. Which is a bit weird. You can see they just got reversed or flipped, shall we say? Yeah? Okay. So it turns out that the ratio of the perimeter of DEF to ABC happens to be the same, but I don't want you to just say, really? Okay. What is the perimeter of triangle ABC? 8 plus 10 plus 14, which is, what is it? 32? All right. And what is the perimeter of triangle DEF?
12 plus 15 plus 21.
Yeah, I'm going to use a calculator. 12 plus 15 plus 21. All right, so this perimeter is 48. So let's look. If I want the perimeter of DEF to ABC, I'm going to use DEF's perimeter first, so that's 48.
So it'd be 48 over 32.
Over 32, yep. But, of course, that reduces. They both reduce by 16. 48 divided by 16 is 3, and 32 divided by 16 is 2. So you can see that it turns out that the perimeters are going to also be in the same ratio as the sides, okay? Which makes sense because if they're all that much larger, then the perimeter all the way around is also going to be that much larger, okay? All right, so a little bit on scale factor there. We want to talk about similarity statements. This is really important. We can use similarity statements to know and learn a lot of information. So this is much like a congruence statement where it tells us a lot of things are congruent. A similarity statement is really informative as well. Similarity, the symbol we use is a little tilde, like that. It's a little squiggle. A little tilde, little squiggle. All right, a valid similarity statement must match corresponding angles and sides. Write a similarity statement for the triangles above. So I can pretty easily say, hey, looking at triangle ABC, I'm just going to write triangle ABC. is similar to triangle DEF. And again, that's just because I'm starting with angle A, that matches angle D, angle B matches angle E, and so on and so forth. So this is a valid similarity statement. It tells us a lot of information, and let's use that here in this next one. So we want to list all the congruent angles and write a proportion that relates the corresponding sides. So again, this is the important part we need to understand. So they're giving me information. I'm going to use that information to mark up my picture. So angle J is going to be congruent to what?
Angle P.
It's going to be congruent to angle P, and I'm going to mark my picture. Angle J is congruent to angle, oh, whoops-a-daisy. I need to mark them with the same marking. There we go. Angle J is congruent to angle P, again, because they were both in the first positions. All right, what else is congruent? K is congruent to angle M. All right, angle K is congruent to angle M. And let's see, angle K is congruent to angle M. And lastly, L is congruent to angle N. Angle L is congruent to angle N. Waz, you of all people should be listening.
Oh, wow.
All right. Now,
Taking all of that.
now that we have the angles listed, we can also find their proportional sides. This is really important. Are these figures oriented the same way?
No.
No, they're not. They're not oriented. They're not nicely lined up. They're not aligned. They are twisted around. Yes, translated and spun, rotated. So I'm going to say this side JK. JK is proportional to which side? PM. Yes. JK is proportional to PM, and that doesn't mean that they're congruent, so I can't mark them as congruent. I'm going to put little stars to just say that those are proportional. Let's see. KL is going to be proportional to? Nope. MN. So here we have a little smiley face. KL is on the side that has the double and the triple mark. So that's going to correspond with MN, all right? So MN, all right? And then last but not least, JL is going to correspond with NP. It's going to be proportional to. So again, those are very important, using those similarity statements. Okay. Turn the page. Number 4. Yeah, we're going to skip down to number 4. Do I want to skip down to number 4? I kind of don't really want to skip down to number 4.
I think I got it. I got it.
We're going to
I
go...
want to try number 2.
Let's try number 2.
That looks like an interesting.
Number 2? Okay.
That looks weird.
So why does it look weird on number 2?
They're not both triangles.
It got like a thingy in the middle. It's got like a bridge thing.
Trapezoid. No, like
It's kind of like the thing from last thing, where he goes through, and it's like not a
two triangles.
There's 2 triangles. Yeah, so these are called overlapping triangles. I'm kind of glad you're asking about it. So what we have here is overlapping triangles. We have triangle XYZ. So triangle XYZ is the large triangle. What I'm going to do is just sort of ignore that middle piece and maybe just redraw that second triangle, which was triangle RYS. So anytime you have overlapping triangles like that, it does help to kind of ignore and separate the two. So I've sort of ignored that overlapping portion and redrawn that little triangle. And again, we can use the similarity statement. This is the key information here. It tells us everything we need. So angle X is congruent to angle R. And angle Y is congruent to angle Y. That is the reflexive angle that they both have. Okay, they both have that same reflexive angle in both triangles. And then angle Z is congruent to angle S. Again, because they are all in order up here in this statement. It's really easy to see. And then, of course, we can also get their corresponding sides. We can do it from the similarity statement as well. XY corresponds to RY, absolutely. We can also do it on our picture here. XY is this top side, and that's RY on the top side. And that's proportional to, I can use my similarity statement again. YZ corresponds to YS, the last two letters. So that corresponding, that little similarity statement is really, really clutch. And then,
so XS is over RS?
so XZ.
Oh, XZ.
Yeah, yeah, the first and last letter, so XZ corresponds with RS. All right. So really good strategy anytime you have overlapping triangles is to separate them, redraw. Makes it a lot better. And those are going to come up a lot. Okay. I just kind of want to skip those two for now. Let's go right down here. This is a problem you're going to see in Delta Math. This is from Delta Math. And we're going to learn how we can use similar figures to solve for lengths of sides. So go ahead and write this down. This is triangle KLM. Triangle KLM is similar to triangle NOP. And it wants us to find PN. PN as in the length of PN. How long is the segment PN? We have two triangles. We have triangle MLK. Huh.
The day we should have off.
Hey, preach.
And then we have triangle PON.
I have a dream. George Bush does not support black people.
I have a dream that we didn't invade Venezuela.
I have a dream that all schools have MIK day off.
Well, you guys also get February, you have your midwinter break in February. So you guys get a Friday and a Monday off. Teachers don't. All right. Okay, we have some information here. We have a 14 and a 19 and a 5. Now, it wants us to find the length of PN. PN is right here. And if I don't know what it is, what can I call it?
X.
X, yes. So we're going to put an X there. Now, you'll notice that these two triangles have the same orientation. And that's really important. These are nicely oriented. But even if they weren't nicely oriented, we have a similarity statement. So I would know that angle K corresponds with angle N, and angle L corresponds with angle O, and that third angle must also be congruent. And if I know that, what I can do is set up a nice little proportion to solve for the missing side. So I'm going to set up these little ratios we've been writing. Let's say I can do 14. Here's side 14. 14 corresponds with X. So I can write that ratio. 14 over X has to be equal to, and I started with 14, so I'm going to go over here to 19. 19 corresponds with 5. And so what I've done is I've written my little corresponding ratios, and we can set them equal, and we can use that to solve. So we are cross-multiplying. So I'm going to multiply x times 19, which is 19x, and that's going to be equal to 5 times 14. I don't know what that is. 5 times 14, 70. And then how do I get x by itself?
You divide by 19.
Divide by 19. So I get x equals 3 point, if I round to the tenths place, 3.7. 7 approximately. Okay? So our job for most of the problems you're going to see today, this is what we're doing. We are writing proportions of corresponding sides. Okay? So let's look at number 6. Again, we have a lovely similarity statement. Are these triangles oriented the same way? No, they're not. So we need to think really, really carefully and use this similarity statement. So I'm going to mark up my pictures. So angle A corresponds to angle D. And then angle B corresponds to E. And angle C corresponds to angle F. So it's really important that you mark your picture, and now we can write our proportions. So if I start with X, what does X correspond with in the other triangle? 25. Very good. So I can write X over 25 is equal to, again, I started over here on the left triangle, so I need to use my left triangle again. So 28 corresponds with 20. So 28 over 20. So you'll notice I did left to right and left to right as I set up my proportion. It's really, really important. How do you get X by itself here?
Divide by, cross multiply, and then you divide by 7.
I could. Do I have to cross multiply on this problem? Our job is just to get X by itself, right? Which turns out to be okay, easy here. Can I just multiply the 25? So if I times by 25, that just goes away. All right, so then we get X by itself. All right, so then over here I have 28 times 25, and then divided by 20. Could do it all in one line if you wanted to. 35. All right, here we don't have a triangle, we have quadrilaterals, but the same is true. PQRS is similar to WXYZ. So again, I'm going to mark up my picture. So P corresponds with W. Q corresponds with X. R corresponds with Y. And I'm just going to use a dot for the last one. S corresponds with angle Z. And once I have that, now I can see where my corresponding sides are. So where do you guys want to start? What number do you want to start with? 75? That's what I heard first. All right, so 75 corresponds with? 40. Very good. Again, that 75 is on the single and the dotted angle. So I want, again, the single and the dotted angles, so 75 over 40. And then, again, I started with 75, so what's my next thing I can use? X. X over 32. Very good. All right. Now, again, how do you get X by itself?
You cross multiply.
You could.
You multiply 32 to 75 and then divide by 40.
Yeah, we can just multiply by 32 because our job is really just to get X isolated. So we need to get rid of the divide by 32. All right, so I can do, let's see, 32 times 75 divided by 40. I get, 60.
I can't move.
All right. Do you have questions for me?
You're so mean. You're so rude. Come on. Great way to put that.
I think we're going to do this tomorrow, so I think we can stop there. All right, I'm going to leave that there.
Never heard of a baffle.